guys, this video's title is The Derivative by Definition. Okay, and before I write even a single thing down, let me just say how picky I and every other math teacher will be about your notation as you are doing this process. Seriously, if you miss the notation on even one line, I'm gonna give you a 0 on the whole assignment and you don't get to make it up. Okay, so I'm going to do 2 examples. I will show you exactly what I'm expecting. No, you can't skip steps. No, I don't want you to do stuff in your head. I need to be able to see it. Okay, so here is what we're doing. We are going to be finding f prime of x. Okay, so that itty bitty little thing, f prime of x. It's called the derivative. And what it is by definition, it's the limit as h approaches 0 of the difference quotient. So if you were wondering why I made you learn the difference quotient last week, or maybe it was the week before. No, I think it was last week. It's so that this part is actually easy. Like you already know how to do this part. Actually, it was 2 weeks ago because 2 weeks ago you learned the difference quotient and then you've been learning limits. All right, we're gonna put all of that together today to find what's called the derivative. And then next week, I'm so excited, you actually get to put the derivative to use. It's really kind of cool. Okay, so anyway, let me start with something really, really simple, okay? I'm just gonna start with a line, okay? So f of x equals 2x plus 3. That's a line. We're going to find the derivative of this line, okay? So I'm gonna use this right here. I'm going to find f prime of x. It's gonna be the limit as h approaches 0 of the difference quotient. So let me compute the difference quotient here. So it's gonna be 2 times x plus h plus 3 minus the original function all over h. Okay, now this notation and the limit have to come down with every single line, okay? Because if you'll notice, I can't plug 0 in, right? I would get something that's undefined. So I'm going to simplify this, right? I'm going to distribute and combine some like terms in the hopes that maybe I can get something to deal with this h. Okay, so that 2x and that negative 2x cancel out. That 3 and that negative 3 cancel out. Oh, check it out. That h and that h now cancel out. So my problem looks like this. The limit as h approaches 0 of, okay, what do I have left here? A 2. Okay, you learned that the limit of a constant is the constant. So now that I've actually taken the limit, I can get rid of that notation. So I have the derivative of this original function equaling 2. Okay, let's try a harder one. Let's try one that has a quadratic in it. So here's an original function. Let's do x squared plus 5x minus 2. Okay, so I'm going to do the derivative. So here it is. F prime of x is equal to the limit as h approaches 0, and now I have to do the difference quotient. So x plus h squared, 5 times x plus h, minus 2, and then I'm going to subtract the original, and this is all over h. Okay, bring the notation down, every line. Okay, so foiling, distributing again. Okay, so now some of the stuff will cancel out. That x squared and that negative x squared, that 5x and that negative 5x, that negative 2 and that positive 2. So let me, sorry, my pencil is giving me some issues. The limit as h approaches 0. Okay, so I am going to factor an h out of the top, which gives me what? 2x plus h plus 5 over h. So now that the h's cancel out, right? Now that I no longer have an h in the denominator, right, which would have been a problem trying to plug in, but now it's gone. Now I can go ahead and evaluate this by plugging in 0 for h. So that means I now have this derivative to be, because that's a 0, 2x plus 5. Okay, so let's do the final example here. You should find this on your notes. We're finding the derivative, again, by definition. So let me make sure that I have the correct notation. All right, so we've got the limit as h is approaching 0. And now I'm going to enter in the difference quotient. So 2 times x plus h squared minus x plus h minus the original function all over h. Okay, and notice again, I will kind of hound you about this, but you need this notation all the way down. So let's see, I need to FOIL this and distribute the 2. Okay, and I'm very confident that you guys are smart enough to do that all in one step. Let me distribute that negative and that negative all over h. Okay, now some stuff's going to cancel out. I'm going to switch colors so you can see that. Cancel, cancel, positive x, negative x. Is that? I think that's it. Okay, so now let me factor out an h. So the limit as h approaches 0. If I take an h out of the numerator, I am left with 4x plus 2h minus 1 all over h. Now I can cancel this, right? And if I now take the limit, right? Now I can take the limit and I don't have to write the limit anymore. This ends up being 0 because you plug in a 0 and you get 4x minus 1.